Hello, my name is James MacDonald. My student ID is ST203-17466, and today I'm here to discuss the implementation process of my electronic voting system for class representatives in schools. This project I designed serves the purpose of allowing students to vote for their chosen class representative. The target audience for this system is for both teachers and students, because if I designed a system that wouldn't appeal to the teachers, they likely wouldn't allow my project to be used in their classrooms. And if the project is too complicated or poorly functioned, the students wouldn't want to use it. The most common voting methods in education are writing answers anonymously on pieces of paper or raising hands to collect their answers. But an electronic voting system is more efficient than a paper ballot voting system, and hopefully also entices the students to create their own electronic projects. While designing my electronic voting system, I had to consider many things, including functionality, aesthetics, ease of use, where I would place the buttons, LCD, LEDs, and jumper wires, and how to code the system. For the functionality of my project, I wanted to make a system that can allow users to cast a vote for one of four options using physical push buttons. Each button will correspond to a candidate. When a button is pressed, the system registers the vote, provides visual feedback, and updates the displayed results. The visual feedback is provided through LED indicators to confirm a vote has been registered, and the 16:2 LCD will display instructions, confirmation messages, and results. For the aesthetics of my project, I did my best to keep the jumper wires short and routed along the edges of the breadboard. I placed the LCD next to the LEDs and the buttons on the opposite sides of the breadboard. In all honesty, I prioritized functionality over aesthetics for this project. Originally, I wanted to use an I2C module for the LCD to reduce the amount of jumper wires and manual pin mapping. And the backlight of my LCD was fairly dark because I couldn't find a potentiometer in my kit. But my project is still functional. To make sure my project was easy to use, I made it so unless the user presses an incorrect button and votes for the wrong person, they physically cannot make an error. I'll showcase later in the presentation where I placed all the physical components, but to program my project, I used Arduino IDE with the C++ programming language. Here are some of my design sketches. On the left, we have a flowchart, and these two are diagrams of how I want my module to be. Here is a list of the materials and components I used to create the project. I used one 16:2 LCD, one Mega 2560, one breadboard, two LEDs, one USB cable, two 220 ohm resistors for the LEDs. I used one 1K ohm resistor, one 10K ohm resistor, 9 jumper wires for button connection, 2 jumper wires for the LEDs, 13 jumper wires for the LCD, for a total of 24 jumper wires. And the software application I used to program my project was Arduino IDE with the C++ programming language. To build my project, I decided to split it into 3 parts, build them and test them one by one to make sure they were wired correctly. Then I could just change the specifics in the code to fit the project. For example, I began with the LCD, wired it and coded it to just display LCD is working. I then tested the buttons were working correctly by using the serial monitor tool in Arduino IDE. And finally, I tested the LEDs work after the buttons have been pressed and the output is displayed on the LCD. For this project, I had very little experience using Arduino and wiring breadboards, so I faced multiple challenges while building my project. First, I experienced some issues with the buttons. Originally, I planned on placing the buttons to straddle the groove in the middle of the breadboard, But I ran into issues with this because the 3x3 buttons have 4 legs that are angled in a way that cannot be wired while straddling the groove. The buttons work adjacently, so 2 legs are meant to be connected to the Arduino through a jumper wire, and the other 2 need to be connected to the ground rail. Essentially, I would have needed to rotate the button 90 degrees on the groove, which was impossible to do because of the way that the buttons were set out. This really confused me because I didn't know that internally the button had 2 opposite sides. While I had the button straddling the groove, I would press them and nothing would show on the serial monitor tool. But moving the buttons and rotating them 90 degrees fixed the problem. The second challenge I faced was with the LCD. In all honesty, I'm not happy with the finished result of my LCD because the backlight isn't bright enough. There are 2 key reasons for my LCD being dark. First, I used a 220 ohm resistor between the 5V and A pin. This is a safe way of engineering that protects the backlight from damage, but it limits the brightness. And second, my contrast was not optimized because I didn't use a potentiometer and instead connected VO to the GND directly. The third and most difficult challenge I had to overcome was learning to code with C++. I've used other programming languages in the past, like Python and Visual Basic, but I've never used C++ before. To do this, I first learned how to use variables for different data types. For example, the total votes needed to be declared as an integer and stored using arrays. I then learned how to use if statements, for loops, and while loops. Next, I learned how to use the Liquid Crystal library to help control the LCD display. By including the Liquid Crystal library, it created an LCD object and it allows the LCD to be controlled using simple commands. I used AI to help me test and troubleshoot my code, and I also used it to help register the votes. On the implementation page of this presentation, the links will take you to videos of me during the implementation phase, where I was just testing to see what works. And this link will lead you to a video of my completed project functioning. Throughout this project, I learned many things. As I previously mentioned, this project was my first time ever using Arduino and programming with C++, but I can now confidently say that I've learned the fundamentals of C++. I learned how to use arrays, functions, and variables, how to use libraries, and how to use conditional statements. Next, I learned how hardware interfacing works and how hardware and software work together while building my project. I learned how to wire buttons, LEDs, and LCDs, how to use a breadboard and the power rails, the importance of using ohm resistors. Throughout the process of me building my project, I improved my debugging and problem solving skills while testing the components step by step, locating my wiring errors and the problems with my buttons. And some other skills that I improved during this project are my design and planning skills, my time management skills, my technical skills, and my programming skills. There are some improvements that my project would benefit from to improve the functionality, usability, and robustness of the electronic voting machine. The most necessary enhancement would be adding a contrast potentiometer for my LCD display. As shown throughout the videos of my project functioning, I couldn't get the backlight of the LCD to work, which makes the text on the LCD slightly difficult to read. If a torchlight is shone onto the LCD, you can read it more clearly, but I'm sure the teachers and students who are aimed at using this project would not want to do that. They'd rather the project work with no extra hassle. The next enhancement I wish to make is to add to the code. So in the event of a tie in votes, the LCD will display that a tie has occurred. And the final enhancement I would like to make is a reset button for the application. So instead of manually taking out the USB and plugging it in again and then rerunning the code, the system can be reused with a push of a button. In conclusion, I can say that I thoroughly enjoyed this project. As I've said, this was my first time ever using Arduino, and I hope I can use it to make more projects in the future. My only real regret of this assignment was that I couldn't find a way to get the backlight of my LCD to work, but in general I'm proud of the project that I created. There were parts of the assignment that I found difficult and confusing, but it always feels rewarding to overcome challenges and understand where you went wrong.